Okay, well now we are doing 255. I know you guys are trying to copy my answers already. Use your algebra tiles to build these rectangles with the given dimensions. So I'm going to use the online ones, and we're going to go only through A, B, C, G, and H. So on this first one, please try to build it first. So if you need to pause this video, pause. Okay, so your dimensions of this one would look like that. So now you'll see that you have the x plus 3 and then the 2x plus 1. And so that's what that one would look like. And then to find it as a sum, again, you just take inventory. You have 2x squared, 7 x's, and 3 1's. And so check your answer on A. And then pause and try B. No, really, hit pause. Okay. So on B, you're looking for 2x times x plus 5. So what that one looks like is we have 2x and then we have x plus 5 down here. So then when you take inventory, you have 2x squared and you have 10 x's. For C, hit pause again. Okay, for C, you have 2x squared plus xy. So you'll see your dimensions. Here's your x, and here's your 2x plus y. So then when you do your inventory, you have 2x squared plus xy. The next one we're going to try is G. So give that one a shot before you continue on in this video. Here is that answer. You have the 3x plus 5, and then this one down here is 2. So your rectangle should look like that. Now on this one, I was deciding if I wanted it to go long or sideways. So if yours went sideways, that's okay, as long as your two dimensions are an x and a 2 and then a 3x plus 5. So when you take inventory, you got 6 of these guys and you got 10 of those. And then finally you have H. So check that one real quick, or try that one before you check your answer. Here you go. So this one, I needed one dimension to be 2x plus y plus 3. And then since this one had the y in it, I knew I needed this one to be y, which to get it to match up, I'd have to use the xy tiles. And so on that one, you have 2xy plus y squared plus 3y. And that is how you do 355. On 366, now we're going to try to do the distributive property without algebra tiles, which I'm pretty sure we've done before. So these you should just be able to check your answer. 2x times 6x is 12x squared. 2x times 5 is 10x. So you're distributing whatever on the outside to everything on the inside. So 6 times 4x, 6 times 1. 3y times 4x would be 3 times 4 is 12, so you get 12xy. 3y times 3 is 9y. Same thing down here. 7 times 10 is 70. xy, 77, y squared. And finally, talking about closed sets, if you read all of this, basically what it says, like whole numbers are closed sets under addition, because if you add 2 whole numbers, you get a whole number answer, like 3 plus 5 is 8. Subtraction is not closed with whole numbers, because if I took 5 minus 3, I get 2, which is a whole number. But if I take 3 minus 5, I get negative 2. Negative 2 is not a whole number because it's negative. So we want to know if integers are closed under addition or subtraction, or addition and subtraction. Give examples and then figure out how you can know if those rules work. Addition, if you add 2 integers, you're going to get an integer. So here's some like proof of that. 4 plus negative 7, negative 3 plus negative 4, 4 plus 3, negative 4 plus 7, all of those give you an integer answer. You could try anything you wanted. As long as you're adding 2 integers together, you will get an integer. Same thing actually with subtraction. If you subtract 2 integers, you will also get an integer. So again, I tried subtraction. And then kind of what I did, if you're like, how did you pick all of those random things to do? I always try 2 positives, 1 positive, 1 negative, putting the negative in front to see if that changes anything. So negative, positive, and then 2 negatives. to see if they work. So to me, if all 4 of these make it true, it really won't matter if I use bigger numbers or smaller numbers or whatever, those would work. And then you can skip B and get started on your Go formative. Thanks.